Hello there again. Last time we had looked at simplifying radicals and adding and subtracting radicals. Today we'll look at multiplying and dividing radicals. Before we get there, let's recap a few properties. If the square root of a and the square root of b are real numbers, in other words, you can actually take these square roots, then the square root of a times the square root of b is equal to the square root of a times b. The a and b can sit underneath the root, the square root symbol. Similarly, the quotient rule says the square root of a divided by the square root of b is equal to the square root of a over b, as long as b is not 0. And another property, if a is bigger than 0, if a is positive, in other words, the square root of a times the square root of a, just like this property up here, would be the square root of a times a, which is the square root of a squared, which we can also write as the square root of a squared, because we have square root of a times the square root of a. So these are equivalent, and that's just a. As long as a is positive, we can do this. As long as a is positive. Okay, let's get to multiplying some radicals. Okay, let's take some simple examples to begin with. Supposing I want to multiply the square root of 7 times the square root of 3. Well, we can combine the 7 and 3 underneath the root. So we have the square root of 7 times 3, and 7 times 3 is 21, so we have the square root of 21. So this is kind of the reverse of simplifying radicals. We're kind of going the other way, we're breaking it apart. Here we have the square root of 3 times the square root of 3. Well, that's the square root of 3 all squared. And that's just going to simply be just 3. So when you have a square root times itself, you just get the number back, the radicand, whatever's underneath that radical. Here we're going to use the distributive property. The square root of 5 times, in parentheses, the square root of 5 minus the square root of 2. So we can distribute the square root of 5 just like we did before. Using the distributive property, we multiply the square root of 5 times the square root of 5 and the square root of 5 times negative root 2. So square root of 5 times square root of 5, so we'll have the square root of 5 all squared here, minus, if we put this root 5 and this root 2, we combine them together, we get the root of 5 times 2. And the square root of 5 squared, as we've seen, is just 5, minus, the square root of 5 times 2, 5 times 2 is 10, so this is the square root of 10. So the solution to this one would be 5 minus the square root of 10, if we were to multiply this through. Now let's throw in some variables in there. Alright, here we have a root 3x, and we want to multiply that times root x minus 5 root 3. So we're going to use the distributive property, which says multiply root 3x times root x, and then multiply root 3x times 5 root 3 times negative 5 root 3. So if we do that, what we're going to get is root 3x times x, so we combine these two, what's under the root here, 3x and x, minus, well, the 5 stays outside, but we have root 3x and we have a root 3, so we have root 3x times 3. And so when we simplify that, we're going to get x times x is x squared, so we get root 3x squared minus 5 root 9x. Now, we've seen before, when we take the square root of x squared, we can just get x. So we can actually pull an x out of here to have x times root 3, because the square root of x squared is x, minus 5. The square root of 9 is 3. So we could have 5, we pull the 3 out, 5 times 3 root x. The square root of 9 is 3, so we could take that out. We could have seen that here, actually. We see we have x times x and 3 times 3. And so finally 5 times 3 is 15, so we'll have x root 3 minus 15 root x. And that's our final answer. Let's do another one. Here in this problem, we're asked to multiply root x plus root 2 times root x minus root 7. Now, you may recognize that we have actually two binomials here. We have a binomial, 2 terms here, and a binomial here, 2 terms. So we will use the distributive property to multiply, but we use the method called FOIL. Remember that when you're multiplying two binomials, you use that FOIL, which is an acronym for first, outer, inner, and last. That's what FOIL means, or stands for. Okay, so let's follow that method. So first would be root x times root x. Root x times root x gives me root x times x. That's first. Outer is going to be this one here. Root x times negative root 7. So we'll have a negative, and then that'll be a root 7 times x. Then inner, think of this as inner here. Root 2 times root x is plus, so we have plus root 2 times x. And finally, the last would be root 2 times negative root 7. So that would be minus, and underneath the radical you'll have 2 times 7. So as we foiled out those two binomials, now we have to combine terms and simplify if we can. So here we're going to have the square root of x squared minus the square root of 7x plus the square root of 2x minus the square root of 14. And the only thing now we can simplify further is we know the square root of x squared is x. So we'd have x minus root 7x plus root 2x, square root of 2x, minus the square root of 14. And so that's our final answer. Now sometimes when you're multiplying radicals, you have a special situation where you can have a difference and a sum. The same two numbers here, root 5 and root 5, and then 7 and 7. But here we have a negative 7, and here we have a positive 7. These are called conjugate pairs. In other words, the only difference between these two binomials is the sign in the middle. And when we multiply these two, we're going to get, we're going to see it actually simplifies quite a bit. So let's do it. We're going to use the FOIL method. Using FOIL, we'll have root 5 times root 5, which will be, I'm going to say 5 times 5 is 25, so we'll skip there, think of that. 5 times 5 is 25. Then FOIL is outer, so we're going to have 7 times root 5 here, plus 7 times root 5. Then the inner product is these two, minus 7 times root 5. And then the last product, which will be minus 7 times plus 7, gives you minus 49. 7 times 7 is 49. So let's simplify this a little, if we can. The square root of 25, we know, is 5. Now, here's where we have a sum of the difference. What happens is we're going to have a cancellation of these inner terms here. We have a plus 7 root 5, a minus 7 root 5. So they're the same number except at opposite signs. They're going to add to 0. So those essentially cancel out. We get rid of them. They go to 0. And all we have left here is minus 49. So we have 5 minus 49. And we can do that subtraction. 5 minus 49 is negative 44. So that happens when you have a conjugate pair, sum and a difference, and you multiply them out. You end up simplifying quite a bit.